Today we're going to talk about radians in a little bit. And one of the things that you need to be sure is that your calculator is set in the right mode. Okay, and I don't think this is going to affect these problems, but it will in the future. Now, for right now, all we know about angles is that we measure angles in degrees. Well, later on, just a few more minutes here, I'm going to teach you that there's a thing called radians that you can also measure an angle in. Well, for right now, your calculator needs to be in degree mode and not radian mode. Okay, so if you hit your mode button there, and you go down to the third line, most of them, probably, especially if you rented one from me, is going to be in the degree mode. Okay, but the default setting is radian. All right, it needs to be in degree mode right now because that's all we're referring to is just angles in degrees. So you go to mode, and if it's like this, if it's set to radians, you just arrow over to degree and you hit enter. Okay. Now, I'm gonna quit out of this and let's do number 20 there. Okay. So the directions where you had to change this from degrees to degrees, minutes, and seconds. So all you have to do is just type in the number, either negative. No, you don't have to. Okay. And the reason why you don't have to is because it's in degree mode. Okay. And really, I'm not sure if it has to be in degree mode or not. All right. And it still worked. Okay. So if you go to where do we get to change it to degrees, minutes, and seconds? On the angle menu. So you go to second, and then your angle menu, which is your apps button. And you use that fourth command there. All right. So what does that stand for there? Yeah, degrees, minutes, seconds. So it's going to take negative 183.47 degrees and to change it into degrees, minutes, and seconds. Okay. Now let's look at the other way around. Let's look at one from 24 through 29. You'll have a particular one. Let me just pick the first one here. Okay. Now notice in these, coterminal angles aren't necessary. Okay. Coterminal angles is when if I want to know where is an angle at on my coordinate plane, that's when I might need to use a coterminal angle. So it doesn't matter if the angles are more than 360 or if they're negative. Now, let's do number 24. So all we have to do is just punch this in and basically just hit equals. So we got to punch in 23. Now we have to put the degree sign. So you got to go to the angle menu. We go to second, and then the angle menu, degrees, and then we got 14 minutes. So I got to go to the angle menu to put in the minutes. And now the other one was 30 seconds. Now, we had a big discussion about this yesterday, but the seconds menu was, or the second symbol was not where you would think it would be, right? You think it would be under the minute symbol in the angle menu, but where was it? Yeah, above the plus sign. You hit alpha and then the plus sign to get the seconds there. And all you have to do is hit enter. And it just says round to the thousandths place, so that'd be 23.242, and it would be in degrees. Okay, so in the scientific calculator, if you happen to use a scientific calculator, which if you take trig in college, they don't allow you to use a graphing calculator. On your scientific calculator, it's this button right here. You'll see where it says degrees, minutes, seconds on your scientific calculator. Same thing. It just pulls up a menu. It's actually easier on the scientific calculator. Let's see. Yeah. And see, there's degrees, there's minutes, there's seconds. If you keep arrowing over, that's degrees, minutes, seconds where it'll switch it for you. Okay. So it's really easier on the scientific one for most trig stuff. Now, y'all check these other problems real quick. 45 through 50. All right, you were finding a coterminal angle in between 0 degrees and 360 degrees. So there's only like one or two things that you have to do to find it between 0 and 360. What is it? Right. Subtract 360 or add 360. Okay. So if it's more than 360, like number 45, all we got to do is subtract 360. And if we have to do it more than once, then you do it more than once. Okay. If it's negative, like on number 46, all you have to do is add 360. Okay. Do y'all want me to do any of those for you? Okay. Somebody said you got them all wrong. Mm-hmm. Oh, okay. I thought you said you got them all wrong. Okay. All right. Now this is it's not really hard, but it's really really important because if we want to visualize where an angle is, that angle needs to be in between 0 and 360 degrees. So like on number 45, we got to understand that 400 degrees and 40 degrees are at the same location. Okay, both of them are in the first quadrant, but 40 degrees, I can tell you what quadrant that is right away, whereas 400 degrees, I can't do it. So that's the advantage of a coterminal angle. Now, let's check the reference angles now. You had 51 and something else. Yeah, 51 and then 52 through 57. Okay. All right, y'all check over these. We'll go through the reference angle rules. All right. Now, let's go through the rules real quick. Okay. So if my angle is in the first quadrant, like I don't think there was any in the first quadrant there, were there? Okay, there wasn't. But anyway, if it's in the first quadrant, then the reference angles, how do I find it? It's the same. All right. If it's in the second quadrant, yeah, subtract 180, 180 minus the angle. If it's in the third quadrant, angle minus 180. All right. If it's in the fourth quadrant, 360 minus the angle. Okay. Now, what about some of these like 54 though, and like 57, where you really can't tell what quadrant they're in because they're so big? Right. You're finding what when you say subtract 360? Coterminal angle. So like on 54 and 57, and then the two negative ones right here, you would add 360 to them a couple of times. You find a coterminal angle, and then you can find the reference angle. All right, question? Uh-huh. Then the answer would be whatever the coterminal angle is. You would find the coterminal angle. You mean do one kind of like that? Number 54 is like that. You want me to do number 54? Okay. All right, let's look at it. So when it says 563 degrees, because it's not in between 0 and 360, we can't really tell right off the top of our head what quadrant that's in, can we? Okay. So what we need to do there is find a coterminal angle. Back out now. Okay. So let's see number 54. I'm going to find the reference angle for 563 degrees. Okay. So there again, if we want reference angles, we want to know what quadrant it's in. And if we want to know where it is on my coordinate plane from standard position, we want it to fall in between 0 and 360. So we want to find a coterminal angle. So, all right, we said it, but let's say it again. How do we find the coterminal angle? You subtract 360. What sometimes you have to do it more than once. I think once is just going to get it here, though, isn't it? Let's see. It would be 203. So let's understand 203 degrees. This is not the reference angle. This is a coterminal angle. Okay. Now that we've got it as 203 degrees, we can figure out what quadrant it's going to be in. Okay, right, it's going to be in the third quadrant because what the third quadrant is in between 180 and 270. Okay, so if it's in the third quadrant, how do we find it? The angle minus 180. Okay, so that's going to give me what, 23 there. Okay, so my reference angle there is 23 degrees. Okay. All right. Any other questions from your homework now? Right, right. So if it's already in between 0 and 360, then you know what quadrant it's going to be in. Okay. That's the thing about a reference angle is figuring out what quadrant it's in. Okay. Now, somebody asked an interesting question. I don't remember if it was in here or if it was in second period, but they asked, well, what happens if it doesn't fall in a quadrant? Like, what happens if it falls on an axis? Well, those really, you wouldn't have a reference angles. But those angles that are like that, which would be 90, 180, 270, 0, and 360, they have a special name, and you kind of need to know this. It's on page 278. Okay. Those angles, I call them the corner angles, and that really doesn't make sense, but I just think of the four corners of the compass. That's what I'm thinking about. They're called quadrantal angles. Okay, so your quadrantal angles, they don't have reference angles because they lie on an X or a Y axis. So those are like 0, 90, 180, 270, 360 are your quadrantal angles. Okay, so that's what those are called. All right, now, so you're not going to have to give me the definition of a quadrantal angle on the test, but if I say it's a quadrantal angle, then you'll know what I'm talking about. Okay, now let's look at other ways here to measure angles. Okay, so ever since middle school, you've grown up, you've measured angles in degrees. Now I'm going to show you how to measure an angle in terms of radians. Okay, so radians is another way that I can measure an angle, especially in standard position. Now, we're going to start with this to show you what radians are and why radians are sometimes more beneficial than degrees. Now, it's a lot easier in trig to work with the degrees. It's a little bit harder to work with radians, but radians have an advantage in the fact that they don't not only measure degrees, or they don't measure the angle, but they also can measure distance. And that's the advantage, is a radian can measure a distance and an angle at the same time. Now, what we're going to start off with is like standard position on the coordinate plane, and we're going to think about a circle that has a radius of 1. Okay, so I'm going to draw this circle with a radius of 1 all the way around. Now, this is a special circle, and here we call it the unit circle. Okay, now, what I want us to think about is not necessarily the angles just yet, but what about the distance around this circle? Okay, what's the distance around the circle called? Circumference. Okay, and usually you don't remember this, but the area, I can't think it out. The formula for circumference, a lot of people tell me it's pi r squared. That's area. Okay, circumference is 2 pi r. Okay, or you could say pi times d, pi times the diameter. Now, if my radius is just 1, then 2 pi times 1 would just be 2 pi. Okay, so if I was starting right here, and let's say that this was 1 mile, and from the center, and if I walked all the way around here, then this would be 2 pi miles. If I went all the way around, the distance around the circle is 2 pi. Now, if we were to think of this in terms of degrees, what's all the way around the circle in degrees? 360. So 360 tells me in degrees, but if I say it in terms of radians there, if I say 2 pi, then that is also the distance. Now, 2 pi is like 6.28 approximately, because you say 2 times 3.14. So if I walked all the way around, it would be 6.28 miles. Whether if you said 360 degrees, that wouldn't mean a distance to you. And so that's the advantage of having a radian measure, is a radian can tell you a distance too. Now, I want you to think about this, all right? All the way around is 360, or in radians, it would be 2 pi. Now, what's halfway around in degrees? 180, okay? Now, if all the way around is 2 pi, then what would be halfway around in radians? Pi, or 1 pi, okay? And we can just say pi. Okay, so now this is the conversion factor that we use the most, is that pi radians is equivalent to 180 degrees. So degrees and radians, it's just kind of like, you have inches and feet. There are what, 12 inches in 1 foot? Same idea, okay? The only difference is radians can measure distance, whether degrees cannot. Now, let's see if we can find the other quadrantal angles, okay? So this one would be 2 pi, or if you started, it would be at 0. Now, let's see if you guys can figure these two out. Now, if I go halfway around is pi. What if I go halfway to pi? This would be halfway to pi, wouldn't it? So how do we root halfway to pi? 1/2 pi, or pi over 2. Okay. Now, does that make sense? All right. This is, all right, halfway around is pi. So halfway to halfway, okay, halfway to pi would just be pi over 2. Okay, like if I said this, if I said a distance was 6 miles, you would tell me half that distance would be 3 miles, because it would be 6 divided by 2. So halfway to pi would just be pi over 2. What now? This? That's pi over 2. Okay. Pi. 2 pi. 0. Now, so let's think about this. What would this be in terms of degrees right here? 90. So 90 degrees is equivalent to pi over 2. Okay, so every 90 degrees is pi over 2. Okay, so if I go pi over 2, I could think of this as 2 pi over 2. So this one down here would be 3 pi over 2. Okay, and nobody spotted this. We've been talking about this for just a couple of days. Nobody said anything about my clock. That's a radian clock. Yeah, and you didn't know what it meant, did you? Now you know what it means. Okay. All right. Some of you looked at it and like, I don't know what that is, so you never looked at it again. All right, but that's my clock. My clock is in terms of radians up there. All right, teacher, Miss Monahan gave me that. She left and retired, so she gave me that clock. Yeah, later, not right now. Now, so, all right, do we have an understanding that what radians are angle measures and length measures at the same time? Okay, now what we need to focus on is this. It's kind of hard to work with radians because it's kind of hard to picture where an angle in radians would be. See, if I tell you the angle in degrees, you can pretty much tell me what quadrant it would be in. But if I told you in radians, not so much. Okay, so we're going to do this, all right? We're going to kind of do what the directions on your worksheet say, okay? We're going to sketch the angle. It's going to be in radians, okay? So we're going to sketch the angle, name the quadrant. Okay, I'm just use capital Q for quadrant, okay? Sketch the angle, name the quadrant, and then we're going to find the reference angle. So remember the reference angle is the acute angle formed by the x-axis. Okay, so here we go. Let's start off with this one. All right, let's do 5 pi over 12. Now what you're going to find is most angles here are given, most radian angles are given in terms of pi. Occasionally they're not. We'll kind of talk about what we do when we get that. So 5 pi over 12, what I'm going to do when I sketch it out is I always start to, when I try to figure out where this is I start at pi. Now, instead of calling this pi, I'm going to think of how can I write it as something over 12? Well, that would just be 12 pi over 12. Does that make sense? Because wouldn't 12 pi over 12 just be pi? The 12s would cancel out. Now, why am I writing it this way, though? Because my fraction is in terms of 12s. Okay? So if this is 12 pi over 12, and of course this is 0, all right? What would this be right here then in terms of something over 12? Yeah, 6 pi over 12, because it's halfway to here. So every 90 degrees is 6 pi over 12. Yeah, it's halfway to this. Okay, so this is 6 pi over 12, 12 pi over 12, then this one would be 18 pi over 12. Okay, now that we've got these to kind of go by, we should be able to figure out where this one would be, shouldn't we? Okay, if this is 6 pi over 12, where would 5 pi over 12 lie? Which quadrant? The first. It would be closer to the y-axis than the x-axis, wouldn't it? Because it's only a pi over 12 away, so it would look something like this, probably a little bit closer. So here's 5 pi over 12. Let's label the quadrant. It's in the first quadrant. Okay, now let's identify the reference angle. Now, if it's in the first quadrant, what do we say about the reference angle? It's just the same. So the reference angle would be 5 pi over 12. All right, so yeah, we're going to do some in the other quadrants now. Okay, all right, so the next one, let's do 2 pi over 3. Okay, see if you guys can kind of figure out where this one's going to be. Okay, let's do 2 pi over 3. All right, let's draw it over here. So right here, instead of calling this pi, what can we call it here? Yeah, 3 pi over 3. Okay, so now this will be a little bit different right here. Now, this starts at 0. So just think about just 0 to 3. What's halfway there? 1.5. So this would be 1.5 pi over 3. So every 90 degrees is 1.5 over 3. So we got 1.5 over 3, 3 pi over 3. So this one would be 4.5 over 4.5 pi over 3. So every 90 degrees, we're kind of going like 1.5 pi. Okay. Now, let's look. So where would 2 pi over 3 fall in the second quadrant? Okay. Because what? It's bigger than 1.5, but smaller than 3. That's 2 there. Okay. So probably about halfway, probably a little bit closer to the 1.5, I think there. Yeah, it's going to be in the second quadrant. So how accurate you draw it doesn't matter. What matters is if you draw it in the right quadrant. Okay. Now let's find the reference angle. Now you can use your rules to find reference angles. Now the rule was in the second quadrant is you take the angle and you subtract it from 180. But the thing is that was 180 degrees. Now we're talking about radians. So instead of 180, we need to use pi. Okay. Now, if I'm going to draw it, I'm just going to figure it out visually. Okay. Think about it. The reference angle. Now, tell me here, would the reference angle be this angle? All right. Would it be, what's wrong with this one? This will be formed with the y-axis. Okay. If I did this angle, That's obtuse. So it would be, this angle would be the reference angle. Okay, now think about it. We're saying that the angle is 2 pi over 3. So from here around to here is 2 pi over 3. Now if I go all the way around to the 180, it's 3 pi over 3. So what would the reference angle have to be? To get from 2 pi over 3 to 3 pi over 3, it would just be pi over 3. Okay, so your reference angle would just be pi over 3. Okay, if you're going to draw it, it's just as easy to figure out the reference angle as it is to use the rules when you're in radians. Okay, radians, again, it's a little bit harder to deal with than radians. See, if I gave you this in degrees, you could have told me all this without drawing it. Okay, but radians, you just got to have to think about it a little bit. All right, let's try this one. All right, let's do 7 pi over 6. Uh-huh. Well, we're trying to make it pi, right? So it's just the same number that you put over the denominator because you want it to be a 1. You want it to be 1 pi, right? Okay. So now, if I do 7 pi over 6, then how do I want to name this one? Yeah, 6 pi over 6. Because 6 pi over 6 would be the same thing as just pi. All right, now, so if this is 6 pi over 6, what's this going to be? Yeah, 3 pi over 6. Of course, that would be 0. So you got 3 pi over 6, 6 pi over 6. So this one would be 9 pi over 6. And if I wanted to go again, this would be 12 pi over 6, which is the same thing as 2 pi. Okay, because what? 2 pi is all, you really wouldn't have to do it on this one. Okay. Now there are some, if it goes into the 4th quadrant, you're going to need this one too. Okay. Now, so where is 7 pi over 6? It's going to go into the 3rd quadrant, right? Because if this is 6 pi over 6, it's going to be just a little bit past that. So it's going to be in the 3rd quadrant. Okay. Now, let's talk about the reference angle. So you remember what the reference angle is, the acute angle formed with the x-axis. So this would be the reference angle, wouldn't it? Okay. Now, if this is, we want to measure from here to here. If this is 6 pi over 6 and this is 7 pi over 6, what would just this little reference angle be? Pi over 6. Okay. So reference angle is pi over 6. So notice, what does this part represent when I do it like that? That's what? That's the whole 7 pi over 6. Okay, so just this part would just be the reference angle. Okay, all right. All right, we'll go back. We said that this was, right there was 7 pi over 6. If I start from the initial position and go to 7 pi over 6. Now, the reference angle would just be just this much. So if this is 6 pi over 6 and this is 7 pi over 6, then that is only pi over 6 more. Like 1 pi over 6 more. Does that make sense now? Okay. So if I did like, well, let's just do another one. I can kind of show you that. Let's try, let's do 8 pi over 5. Get some more paper. All right, now what did I say I forgot? Okay, 8 pi over 5. Okay, all right, let's do that. All right, so let's draw this one. All right, so let's think. This would be at pi, I would call it 5 pi over 5. Okay, so halfway to 5 pi over 5 would be 2.5 pi over 5. So every 90 degrees is 2.5 over 5. So it's got 2.5 pi over 5, 5 pi over 5. This one would be 7.5 pi over 5. And then this one would be 10 pi over 5, which is really how much? 2 pi. 2 pi is all the way around. Okay. Now, let's look. Where would 8 pi over 5, what quadrant would that fall in? The fourth, because it would be just past 7.5 pi over 5. Does that make sense? Okay. So it would be about right here. This would be my 8 pi over 5 in the fourth quadrant. Okay. Now let's find the reference angle. So is the reference angle going to be the smaller acute angle or the bigger acute angle? Yeah, the big one, because it has to be formed with the x-axis. Okay. Now y'all think about this. Okay. This is 8 pi over 5, and to here would be 10 pi over 5. So really, what is that going to be there? 2 pi over 5. Okay. Now, give me just a second. I got to start this over before it runs out of